all good. I welcome you to my YouTube channel. This is Dennis, and I'm going to be taking you through something small concerning database management. What you see right on the screen is facts that were provided to me, and with these facts, we shall come up with an ERD using chen database notation. An ERD is entity relationship diagram. Chinese database notation is a data modeling technique developed by Dr. Peter Chen in 1976. It is a kind of graphical presentation of the relationships between entities in a database. Let me show you something down here. This is the data that we are going to use. This data here is what we are going to use to come up with the ERD diagram. So down here is the ERD that I came up with using chen database notation, and this is how it works. Like you can observe, rectangles represent entities, which entities can also be called tables here in database. Where we see ovals, the ovals represent attributes or columns. Where you see these blue diamonds with the lines under them, those represent the relationships between entities. I said rectangles represent entities. Then the ovals represent columns, or what we call attributes. These other straight through lines connect attributes to entities. Now, here's the thing. Let us take an example of patient data. Where we see patient data, that rectangle is an entity on its own. Visitor record is an entity. Treatment record is an entity. Facility an entity. Supply chain an entity. So this is how it works. You know, when you have a table under database, we shall first create a table, then we create columns where we are going to be saving the data that we are going to be collecting from the users of the system. And having us learned that an entity is a table, so the columns are the attributes. Which attributes? We have gender, and these are assigned specific data types which they are supposed to collect. So gender was restricted to variable character, or what you can call varchar, and it is restricted to 10 characters. Like if you're entering your gender, it should not go beyond 10 characters, but it can carry less than 10 but not go beyond 10. So under patient data, we have about 6 attributes. We have gender, we have address, we have the patient ID, we have first name, the last name, and the age. Now you realize that at age we set this data type to be an integer. So meaning you write a number. If you type a text here, it will not allow you to proceed, because we have preset that data to accept only integers. Where you see patient ID, that is the primary key for patient data. You know, a primary key is a unique number or a unique character that identifies a specific entity or a specific attribute. Let's say if we are here registering sick patients, and we happen to have John, who is given a patient ID S01. S01 should only define that specific person to whom it was assigned. Now, going to visitor records, now we can see that blue diamond. The blue diamond is the relationship between patient data and visitor records. And like you see that it is labeled 1 and M, it means that a single patient can visit the facility several times. Like you can visit today, you can visit in the afternoon, you can visit in the evening, you can visit in the morning, whatsoever. So the relationship okays it that the patient can visit for as many times as they feel comfortable. So when you go to the entity that is known as the visitor records, you will realize we have a patient ID, which is already down here as a primary key. So in this other entity of visitor records, we can also see there is a visit ID. So here under visitor record, visit ID is the primary key. So patient ID becomes a foreign key to link us back to the patient data, just in case if we had collected patient data there. So we can link that patient data to visitor record through the patient ID, which is acting as a foreign key under visitor records. So still we come to treatment record entity. Now, what links the visitor record to treatment record is the treatments that this person is coming for, and what shares the data of visitor records with the treatment record is the visit ID, which is acting as the foreign key of visitor records into the treatment records. And the relationship between these two, the visitor records and treatment records, is the treatment. And we are saying that even when a patient has visited once, we can treat that patient several infections. Not like you may be having malaria, you may be having headache, you may be having diarrhea. We can treat all of these complications in the one-time visit that you've paid. So the relationship is one to many, meaning that even when you come a single time, we can treat you multiple kinds of infections at that one time you've come. So that is how it works. We have, what we should understand is we have foreign keys, we have primary keys. Primary keys are unique identifiers of attributes, and a foreign key is a link that will help us get in touch with a different entity. Now we've seen in the visitor records we have patient ID as a foreign key, and under treatment record we have visitor ID as the foreign key, meaning that patient record as a treatment record can link with a visitor record together with the patient data through both patient ID and visit ID. So I hope that is very clear to you now. Like I said, these diamonds represent a relationship between entities. So the relationship between entities is already denoted how it works. Where you see M is many, where you see one is one. So it is one to many. Where you see one, that means for a single time. Where you see many, that means many actions can happen in that single time. So this is we have about 8 entities. So of these 8 entities, like you've seen, I'm going to show you how we can code them in SQL. We create these tables and we create columns where we shall be capturing this data in our database. Right here, let me go to phpMyAdmin, the localhost. Like we said, an entity is a table. So here in SQL line 1, we are going to create a table called patient data. We shall we shall give this patient data a patient ID, and we shall restrict it to a data type called integer and a primary key which is auto increment, meaning that nobody should have nobody should share this unique ID. It is for one item. Like if we say John is taking 001, that 001 should be for John only. Joseph will also carry his, and it shall not be same as for any other person. The first name here, we said the variable character was set to 50. So you can enter digits less or equal to 50, but you cannot go beyond the 50. It will not be accepted. Now, there's something I want you to observe. You can see this patient ID here, which is a primary key. You come down here to visit a record table. We created the table. Still, it has a visit ID called a primary key, and it is also auto increment. But again, down here below that visit ID, there is a patient ID. So what is it doing here right now? Yet we already saw it up there. You remember when I was showing you Chinese database notation, we said there is a foreign key that helps to link two entities. So we are linking the entity, or we are linking the table called patient data to a table called visit records through a foreign key called patient ID. Like you see down here, it is denoted that foreign key is patient ID quoted in brackets. So this thing here, you see, allows us to share information through entities. You have entities, you have a table here, is connected to this table here. Instead of us going on assigning these IDs anyhow, every time we go to a table, we have to write the whole name and what all data. No, we can use these foreign keys to be able to pick that data that was inserted earlier, then we share it across the platform. So like that. Like I said, we have over 80 entities in this chain database notation. So like you see them, you see the first table was patient data, second was visit records, treatment was third, laboratory test, facility. They all work same way like I explained in the first one, the first two of them. We see there are always these foreign keys, facility ID that links us to the facility in their primary keys. Those are the things you shouldn't forget about the SQL. So yeah, this is how we came to go about the SQL code, and this time we are going to run and see whether we don't get errors. So what we are up to is creating a database that is efficient, that can capture data. So I'm going to come here and click on this go. You see this button right here? So we shall deploy the code, and once it has no errors, it will go through. If it has errors, it will tell us that I have errors, you fix me, and we shall fix it. Let's go. Yeah. Now, once you see a tick and an interface of this kind, it shows that we have succeeded. If it had errors, we were going to get error codes from the system. So you can see up here, the database is called Hospitali. You see on top here, it is called Hospitali. So Hospitali is where, here it is, Hospitali. This is the Hospitali. So you see the tables we have created. We have created tables, different tables, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, we had 8 entities, and we have created 8 tables. So let me show you table by table. So let me show you patient data as our table number 1. So now this time we are not going to use SQL. Let me show you the structure of the table. We said that it should be having columns which we called entities, where we had patient ID, first name, last name, age, and what. And next to it is this